Okay, I'm live. Hello everybody, welcome back to another one of Leeds Helpful Tips. Thanks for joining today and happy Veterans Day. Thanks to everyone who served in our armed forces or is serving in our armed forces. We appreciate the work you're doing and the sacrifices that you have made. And also thanks to anyone who is tuning in today. Today's going to be a really interesting, I hope it's going to be an interesting Helpful Tips, Leeds Helpful Tips video. What we're going to be going over is a new product that we have been in the process of building over the last several years. Yeah, I think I can say that. It's been a couple of years that we've been working on it, and it's our new and improved coaxial illumination system. So the whole idea with coaxial illumination is to provide a really another type of light source for a firearm examiner. It's another tool in your toolbox, and we'll go into that in a moment. A couple quick notes before we get started. This is a live stream, so it's absolutely coming to you live from our offices in Minneapolis, Minnesota. But because it's a live stream, things can happen. You know, we can lose the internet, power could go out. Hopefully that doesn't happen, but if it does, if we lose connection or whatever, please bear with us and we'll try to get the signal back. Additionally, one of the advantages of doing everything through YouTube live streaming is if you have a Google account and are comfortable doing it, you can log in and then you can ask any questions that you would like in the chat window, which I think is to the right of the screen. So what I'll be doing is, as I'm presenting, I'll also look over every once in a while to see if we have anything going on and answer questions as they come up. Coaxial illumination. What we have on our system, it's something that we've had customers talk about over the last couple of years, actually longer than that, but what we've finally done is built our new coaxial system. So coaxial illumination, designing it, as with everything else in microscopy or designing things for microscopes, it's always a series of trade-offs. Essentially the idea is with a coaxial illumination, the reason it's called coaxial is because the light comes directly through on coaxis with the optical system. So the idea is when you're looking through the microscope, the light is actually, that you're illuminating your specimen with, is actually following the same path, basically, that you're looking at. And so you get very even illumination, and you also can get very glare-free illumination. So what we've done is we've placed our coaxial unit, and this is what's kind of unique and why it took us a little bit of time to work on. We've actually placed our coaxial illumination system underneath the zoom body as opposed to behind the zoom body. A traditional coaxial system will often be placed behind the zoom body, and the idea there is as you change your magnification, zooming in, zooming out, because a traditional coax system is behind the zoom body, the field of view of illumination will also zoom in and zoom out. It'll literally get bigger and smaller as you change your magnification. The problem, though, is on our comparison scope is if we were to add a coaxial illumination system between the zoom body and the bridge, it will increase the height of the system. Additionally, what will happen is it makes it very difficult to remove entirely from the system. And while coaxial is very useful for lighting, it isn't always necessarily used. And the idea by being able to remove it from the system, the idea there is that one of the fundamentals of coax is that even when you're not using it, it's going to basically steal about 50% of your light. So we do want to be able to remove it when it's not in use. So what we did on our comparison scope is instead of installing it between the zoom body and the bridge, we actually installed it between the zoom body and the objective. And this works, and the reason this still works is while our field of view of illumination no longer changes as we zoom in and out, we actually have bright enough and powerful enough LEDs that we can overcome any intensity loss or any that you'd have by not being able to have your field of illumination change. These are really bright, really powerful LEDs. The benefit it gives our examiners is that it doesn't add stack height to the whole system, which means ergonomically everything is the exact same as basically it would be for regular microscopy. You don't need to try to get up taller on the bridge. You don't need to have to disassemble your bridge and reinsert a coaxial system. It's designed so you can remove it when you're not using it, and then when you're using it, it's very easy to put on. So how does it work? Well, essentially what we do is we have our very powerful LED, fanless, I might add, LED light source located here. And what we do is we shine a huge amount of light into basically a beam splitter or filter cube system that's located in here. That light comes down, it's got a polarizer, comes down, hits the sample, and then we have, it's called a quarter wave plate, but I wrote down the term, we have an anti-flex device on the front. And essentially what this does is it reduces any internal reflections caused by this coaxial system. Kevin can talk a lot more to it in preparation for this presentation. He actually drew me a diagram on the board. I'm going to let him explain that. If people are interested, we can do a whole talk on the polarizing components internally. It's really cool, but for today's video, we're just going to focus on here. But essentially what happens is the setup is designed in such a way with the quarter wave plate and the polarizers in here that you don't get a direct reflection of your own light source. And a direct reflection would look to an examiner kind of like a haze. Imagine if you were inside looking outside at night and you took a giant spotlight and you turned that spotlight inside of your house to try to illuminate something outside, you'd get a direct reflection off the glass. That's what the compensator system and the polarizer system compensates for, prevents that glare. So I'll show you in a quick moment. Actually, I'll just go ahead and show you now. Let's go switch over, and then I'll show you how we can remove the system. So essentially, what the system does and the coaxial system does is that you get this light that is bright. You get light that is directly coming down through the optical system. It's basically glare-free because of those polarizers and compensators. And it's really good. It's primarily used a lot in industry for specular reflection. So think about if you were looking at a mirror surface or a circuit board or something that has a lot of direct reflection. That's what it's used a lot in industry. In firearms work, this is actually a customer's piece of equipment that once it passes quality control, we'll be sending them. But what they discovered is that coaxial illumination works really well on granular breach faces. So whereas fluorescent illumination, let's see if I can get this up. I'm going to go ahead and turn it on. Our fluorescent light source, I'm going to remove our quarter wave plate from the front. It's going to be a little dim because of that, like I had said. If this coaxial system's in place, it's stealing half the light. I'll show you how to remove that in a moment, but just for comparison purposes, yeah, it's pretty dim. But I think you can see it. So this is a known match that was fired from the same firearm. And what you'll see with traditional fluorescent light is while fluorescent light is really good for getting striations, those very fine marks on land and groove impressions, as well as breach faces, the coaxial illumination, let's let our camera catch up, the coaxial illumination allows you to see a lot more of that granular detail. So I'm not quite too sure where this comes from. Maybe it's from the casting or just pocket marks on the back of the breech itself. But that's where coaxial illumination is really used for, is for these granular type of tool marks. And it can be really helpful in trying to get those fine details for that speckling, for those random patterns. Another thing that it can be useful for, just based on how it works, because that light is coming kind of like a ring light, it's coming directly down from the microscope. The coaxial, and this is the coaxial side, I'll go ahead and turn off our fluorescent. It can also be used and be helpful for looking at firing pin impressions. Just a quick note on operation. The way the coaxial system works for anybody who's working on it or has one, it's got that quarter wave plate. Essentially for operation, what you would do is you just rotate this quarter wave plate to its brightest position. And then you're getting that perfect, that non-reflective, you're getting that really, the coaxial illumination. You could also turn it to its darkest position. You'll see how the screen's getting darker and the camera's fighting to compensate. This just turns your coaxial system into reflected light pole. So that's something just to know, that when in usage, you rotate this quarter wave plate compensator until it gets to its brightest position. So that's the coax. It's designed for granular breach face marks. It's really good for that. It's also really good for items that have a lot of specular reflection, and if you want to just like mirrored surfaces. Yeah, it can be really helpful, particularly if you have random chaotic patterns and you're trying to match granular patterns, you can use the coaxial kit to help match those patterns. All right, so now let's get to the nitty-gritty. How do you put this thing on and how do you take it off? Because as you saw when I switched over to fluorescent, it does steal a lot of light for your traditional fluorescent or fiber optic imaging. So this is really cool, and this is a lot of work went into this, so I hope you guys like it. So essentially what you do is, if you watched our other video where Kevin talked about our ultra wide field objective, we're using the same mounting. It's our quick change kit. So essentially it's just 2 thumb screws to remove the coaxial system. So to remove the coaxial system from the light path, simply we're going to loosen this thumb screw here. The objective slides out. I'm going to place it right there. And then what we're going to do is we're going to loosen this thumb screw right here on the other side. It's ambidextrous. We can actually install it on either side. This whole thing slides out, and that's it. There's no wires, there's no cable management, it just slides out. And now we can actually, I'm going to zoom out a little bit, and you'll see there's this component back here. This sticker will come off once we finally QC it. This whole thing will actually just slide right in like that for storage for when you're not using it. And then we can put the objective back in. Oop. You want to hit that dovetail as opposed to be below it, and then lock it, and then you're good to keep going. And then you obviously would do both sides. Something else we're going to probably do is, as we've been doing quality control on this particular system, which again is a customer system, once we finalize the QC and send it out, they'll have the first one. We're going to probably have to put a place to put the quarter wave plates on our setup for when they're not in use. And that's about it. That's the coaxial system. Coaxial system is available for, I would like to say now, again, this is our first production run, but we can certainly quote you it. And what's really cool is, as with our light guide positioning system, our ultra wide field objective, and basically almost all of our other products, we have the ability to retrofit this system in the field. So it's very easy to install, and it's field retrofittable. And it's available now. All right, I'm going to see if there's any questions. There's always a delay, so I'm never too sure, but I think we're good. So, okay, thanks for watching. Again, my name's Jake Kurth with Leeds. If you have any suggestions on helpful tips that you'd like us to go more in depth in, or discussions on, or if you'd like to learn all about the intricacies of the polarizing elements inside the coaxial system, please feel free to email me, jkurth@leedsmicro.com.